Hey, don't mock me when I hit my hand like that. All right, when we graph, let's see this. Okay, these aren't the directions right here from the paper. I think the paper just says to graph this. Okay, do you guys know what form this is in? Someone say y slope form. Slope intercept form. Yes. Now I understand why you said that because the y is alone. What are these numbers? What is the negative 3 over 5 and what is the plus 2? What are those? That's the opposite. Yes. This one is the y-intercept, and here is your slope. Okay, so the y-intercept. Is y-axis vertical or is the y-axis horizontal? It's vertical. So you go to the 2 right there and you graph that point because we know that's a y-intercept. It makes sense too because that point, can you guys tell me the coordinates for this point? What are the coordinates? 0, 2, right? If I plug a 0 into this x, what does y equal? It equals 2, right? Because 0 times the negative 3 over 5 will just be 0. 0 plus 2 is 2. So that's 0, 2, and then we have our slope. Our slope, which is m, see, m equals negative 3 over 5. It's negative 3 over 5. Will tell us to do what? What does the negative 3 and the 5 tell us to do? Yeah, we got to find our next point. In order to find our next point, we follow what the slope tells us to do. The top number is the rise, and in this case it's a negative 3. If it's a negative 3, we're going to go which way, up or down? Down. Yeah, because rise goes up or down, but because it's negative, it goes down. So I'm going to go down 3, right to there. Here, let me count it. 1, 2, 3. And then what's the 5 going to make me do? To the right, how many? 1, 2, 3, 4, 5. All right, fantastic. So there's my other points. I graphed it. I'm done. All right, last one. Midpoint. I'm pretty sure it's the last one. Let me check. Oh, no, there's 2 more. Okay, how do you find the midpoint of these? Well, again, we can draw a picture for ourselves and kind of like figure it out. Let's see. For this one right here, we have negative 4, positive 4, which is right there. And then we have 5, negative 1, which is right there. Okay, you guys want to guess what the midpoint is? It has to be a point right in the middle. Right in the middle of these two. Okay, don't guess. Let's think some. You see the negative 4 and the 5? What's between the negative 4 and the 5? No? What is it? Well, if you remember earlier, if you wanted to find the middle between two numbers, like if you wanted to find the middle between negative 4 and 5, you just have to add the 2, then divide by 2. So I'm going to add negative 4 plus 5, which equals 1, and then I have to divide that by 2, which equals 1/2. And so 1/2 is right here on my number line, between the 0 and the 1. It makes sense, 0.5. Okay, now the other thing you have to do is you have to find the middle of negative 1 and 4. So you do the same thing. You take the 4, you add it to negative 1, you get 3, and then you have to divide that by 2. When you divide 3 by 2, you get 3 over 2. Or you can write that as a mixed number as 1 over, or 1 and 1/5, or 1/2, which is actually easier to graph. So right there. That point does look like it's in the middle of the 2. You guys can look at the formula at the very front page and just plug in numbers there if you'd like. It kind of helps if you label your points. So like if you went x sub 1, y sub 1, and then x sub 2, y sub 2, then you can plug them into your little formula. But I hate formulas. I like understanding it. All right, the last thing is the distance. What is the distance between these 2 points? It asks us to leave in radical form, simplest radical form. That means no decimals. So we could do the visual way. We can graph it. 2, 1 goes right there, and 4, 3 goes right there. We want the distance between these 2 points. If you want to, you could draw yourself a right triangle. And the reason why you would want to do that is because then you can see the distance right there is 2, and the distance right there is 2. Because you can count those. It's nice and orderly. This one right here, you can't count because they're diagonals of the little squares. Now some of you guys might recognize that this is a 45, 45, 90. If you recognize that it's a 45, 45, 90, you know that you're going to use the reference triangle, which looks like this. 45 right there. That's 1, 1, red 2. And then you might think, oh, look, these are 2s and these are 1s. What would this be then? Like, how do you make the 1 into a 2? What would you multiply the 1 to get to the 2? Multiply it by 2. What would you multiply that? Same thing. You multiply by 2. So what would you have to multiply to this to find out this? Multiply it by 2. So your answer is 2, red 2. Now that problem is really nice. You know, you didn't really have to do much for it. If you didn't recognize that, you can use the Pythagorean theorem. You can say, okay, I'm going to pretend that this is x right there, and I'm going to go 2 squared plus 2 squared. That equals x squared. 2 squared and 2 squared, that's 4 and 4, so we have 8 equals x squared. It's a Pythagorean theorem way. It's actually the same thing, just about. You would square root both sides. This would be x. And this side, you would have to simplify the radical 8. If you don't remember how to do this, check out my website in Unit 5. I found someone else's video, and I thought they did a pretty good job of explaining it. I don't have my own video for it yet. So we have radical 4 and radical 2. I chose 4 because that's a perfect square. And 4 times 2 equals 8. Perfect squares simplify. Radical 4, square root of 4 is 2, so I get 2 red 2, which equals x. Same answer, different way to get it. Now, what if you were like, no, I just want to use a stupid formula? Then you can use a stupid formula. The formula takes a little bit longer, though. This is what it looks like. Again, you want to label stuff. This is x1, x or y1. Man, I hate formulas. I hate this way, but you know what? I just want you guys to know how to do this so that you guys can get your credit. So we have the distance equals the square root of this craziness. We have to go 2 minus, is it minus? Yeah, 2 minus 4, because that's what you have to do to find the distance between two numbers. And then you have to go and minus the other one, so 1 minus 3. So we go plus 1 minus 3. That's going to be negative 2 squared. That's going to be negative 2 squared. What's negative 2 squared and negative 2 squared? Yeah, those are just 4. So we have the square root of 4 plus 4. 4 plus 4 is 8. Ah, that's the same thing as this right here. And so we know that this guy simplifies down to 2, red 2. Done.